What is up, guys? Welcome back to Introduction to Linux Bash Scripting. As always, I'm your instructor, Kevin Downs. This is Session 5 of Introduction to Linux Bash Scripting, a course by coding-bootcamps.com. Today, we're going to be going over text manipulation utilities. So in our last session, we went over manipulating strings, writing and calling functions, controlling process priorities, interpreting command line arguments, making scripts interactive, special shell variables, advanced I/O with streams, and improving performance of scripts. Today's session, we're going to be going over editing a file from a script, scripting with ed or sed, Unix and Linux utilities to manipulate files, regular expressions, also known as regex, grep and egrep, the stream editor sed, sorting in scripts, generating reports with awk, splitting large files, counting words, lines, and characters, transforming file contents, and extracting text streams. Let's go ahead and start off here with editing a file from a script. So the first one we got here is sed, which is that stream text editor, okay, which we just saw here. Okay, the stream editor sed. So here we see the format for this sed command. So we have sed, and then the patterns we want, so pattern 1, 2, on, and so on. And then the command and arguments here, okay? So here's an example of it. We have sed-i, and single quotes, we have s/gedit.desktop /yournew.desktop /g, and single quotation mark. Then we have a space, and we have /usr/share/application/defaults.list. So what's going on in this command here? Well, this is saying search in the file user share applications defaults.list, which is here, and saying find gedit.desktop, which is here. It's saying find this in this file and replace it with this, your new desktop, okay? And apply the changes in place, which is -i. So in this file, search for this and replace it with this. Okay, so that's how we can use sed to kind of edit a file from a script. Okay, this is much more convenient than going in there, erasing the line, typing in the new stuff. We can do it in one line with the sed command, and it'll find it, it'll replace it, and it'll put this new line in there, okay? Now, at first, right now, you're probably thinking, well, it's probably easier to go in the text editor and just, do it myself, because I'm maybe a little afraid or a little nervous of this command, or maybe I'm not totally comfortable with it. But once you are comfortable with command line in the sed command, this becomes so much faster and quicker and more efficient for you guys to just be able to zip this off in one line and edit the line in the file. So let's talk about scripting with ed or sed. So an ed script must contain commands to save the file and quit the editor. It produces no output to the screen except what may be generated by a specific command. The stream orientation of sed has a major impact on how addressing is applied. In ed, a command without an address only affects the current line. Sed is a stream editor. A stream editor is used to perform basic text transformations on an input stream, such as a file or input from a pipeline. While in some ways similar to an editor which performs scripted edits, such as ed, sed works by making only one pass over the inputs and is consequently more efficient. So we've looked at these commands before, guys, and these are ways that we can use utilities to manipulate files. These are the Linux commands which may help to create, delete, rename, move, copy, edit, and perform other related activities on Linux files. And we have seen these before, guys, and we've used them before many times. We have cat, which will list the contents of a file, touch, which will create an empty file. However, it won't let you edit it immediately. It'll only create that file, and then you're going to have to open an editor to edit that file. We have ls, or list, to list current files in your directory. mkdir, make directory, to make a directory. We have cd, to change directories. pwd, which is print working directory. We have rmdir, remove directory, to remove directories. We have move, copy, and remove. So move is how you can rename files or move files to another location while keeping or without keeping the file in the same location. Copy, on the other hand, can keep the same name or rename it, but will also create a copy of the file. Move does not keep the original contents. Okay, so it's renaming the inode on them. And then we have remove, and that's how we can remove files. Okay, We also have ln, which we haven't talked about too much, so we'll talk about it now. So ln is link, okay? This is how we can create soft links or hard links, okay? So guys, a hard link is merely an additional name for an existing file on Unix, or on Linux, or other Unix-like operating systems, okay? However, a soft link or symbolic link, unlike a hard link, does not contain the data in the target file. It simply points to another entry somewhere in the file system. So guys, a soft link points to another file in the system. However, it doesn't contain the original data, okay, where the hard link does. So I could delete a hard link or the original file of a hard link, and the data is still going to be there, okay? So I could go to the hard link and it's still going to be usable. A soft link does not have that original data, okay? So if I delete the original file, the soft link becomes useless. This becomes a problem in our scripts if we're using soft links and the file gets deleted, right? It's going to break our script. So let's kind of look at that real quick here to maybe show you what I mean a little bit more. So I'm going to head to my VirtualBox here. I'm going to log in. Okay, so I'm going to do an ls. Okay, you see I don't have the file test yet, so I'm going to touch a file just called test. Okay, ls. So now we see that test file here. I'm going to touch and create another file called test underscore link. We'll call it, actually, we'll say S-link for soft link or symbolic link, okay? ls. So now we see you have that test file, test soft link file, okay? I'm going to clear my screen real quick, do another ls so we have a little bit of space back. So now what I'm going to do is I'm going to do ls-s for soft link or symbolic link, okay? And then I'm going to put the file, or the source file, and then where I want to link it to, test s-link, okay? Oops. I need to spell it correctly. There we go. Okay. Okay. So I need to just go ahead and let it create that file. Okay, so we'll do ln-s. It didn't like that I already created the file, so we'll let it create the file. So test, we'll say test underscore sim link. Okay, that's what we'll do. Alright, there we go. So now do an ls. Now we see this file here, okay, notice it's colored differently, so we have a symlink now. So I'm going to clear the screen, I'm going to do a ls-l for long listing. Okay. You actually see here on my screen, that's pointing to the file it's actually linked to. It's saying, hey, this is actually linked to the file test, okay? I want to show you one more thing here. I'm going to clear my screen, oops. So I'm going to do a link, and I'm just going to say test. I'm going to say hard link. Okay, I'm going to do ls. Oops. Now you see that this file exists, okay? Now what I'm going to do here is I'm going to do an ls-i so I can see the inodes. Now what I want to show you here is notice that the inodes on test and test symlink are different. Okay, so they have different inodes. However, when we look at hard link and test, so I have hard link here, right? They have the same inodes. And why is that? Well, that's because, as I said, the hard link actually has the original data on it, right? So all the same info and same data is in there. The symlink, though, does not have the same information. So if I were to delete test, this symlink would be destroyed. If I delete test here, this hard link would still be usable, okay? So that's important to know, guys, especially when you're creating scripts and they have links in them pointing to different files, okay?